in very carefully. Da, 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 da. Here we go. Lots of measuring cylinders. Now, whenever we're in the bath, there's lots of things that we can buy. So I got this in Lidl, frozen, it says, colour bath water. So I'm going to drop that in there and we get a lovely red colour. And again, when I look at the ingredients, there's citric acid and there is baking soda. And so what they're doing is they are reacting and fizzing, and we're getting this lovely carbon dioxide gas being produced. We can also get these, they're called colour fizzes. So I've got one here. So this is used for flowers. I got this in Home Base. So it's a great test tube, especially for the young ones, because it's got a very wide base, which is going to make it very, very stable. I've got, wow, this is just an old drinks bottle. So my Coca-Cola's been used up, or the water's been used up. I've just cut the top off, and we can put those in there. And I think I've got green there again. I've got another one here, and that's going to fizz, and that's going to give me yellow. And then I've got one here, which is blue. That's going to go in. Oh, there's green, and we're going to put a yellow in there as well. And then I want you to look at this one here, because I'm not going to put a tablet in there. I'm going to put some crystals. So this is washing soda. So the washing soda goes in. You see that lovely pink color? It's awesome. Now, let's kind of move that back a bit there. So what I'm going to do is I'm just going to disappear a little bit around here, and I'm going to move my camera so that you can all see the bubbles clearly. Okay, I think that's a bit better. There we go. And then I can come back again. Moving around this small space. It just disappeared. Okay, now I want to introduce you to another chemical. And this chemical is called dry ice. And engineers use this a lot. And what we're going to do is now, if we can go to my iPad or to my computer, fantastic. And what we're going to see is a little column with candles. So I had talked about this gas, carbon dioxide. So we're going to move that water out of the way here. And we did talk about things being flammable. So whenever we're getting something to burn, we need to have a fuel, we need to have oxygen that's in the air, and we need to have some heat energy. So there we go, we've got my candles there. Da, 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 da. And in the laboratory, scientists will make this carbon dioxide gas, and then they squash it. And when they squash it, I'm not sure you can see how cold that is. It turns into a solid, and it becomes really, really, really cold. Minus 78 degrees this is, so I'm not going to touch it inside with my fingers. But if I put it into some water, so I've just coloured the water, it will immediately kind of boil away. There's a huge temperature difference there, and we get this wonderful gas. So we used helium in the bubbles, and they were rising because they're lighter than air. This gas is heavier than the air that we breathe, so it flows downhill. So if I just pour this, it will go down over my candles, and my candles will go out. Right, now, so I've kind of put that there. And what I want to do now is I want to kind of mess about with my bubbles again. So I'm going to squeeze past that stage there. And I have some dry ice. Okay, look, no expense spared. So if we go back to my iPhone, I've got some dry ice in there. And I'm going to put some water into there. Okay. And hopefully we're going to make some of this gas. And then I've kind of got a tube that I normally use to make weird sounds with. So I'm going to put that there. And then, look, we've got the gas coming out there. That looks quite cool. So we've got our bubble solution. So let's kind of use our bubble solution and let's see what we can do here. So if I move that over there, if I dip it into my bubble solution, you didn't see it earlier, but I knocked it, it went all over the floor. So we're going to put a little bit more of it in there. There we go. And I'm hoping, well, what do you think I'm hoping I'm going to do here? Yeah, this is exactly what I'm going to try to do. I'm going to see if I can get these bubbles filled. Look at that, with carbon dioxide. And they're white, they're just like ghosts. They're like boo bubbles kind of falling there. Now this is the liquid that I use to be able to bounce my bubbles with. So I'm going to put my glove back on and we're going to see if we can kind of catch one of these bubbles. Oh, goodness me. That would be cool, wouldn't it? To be able to hold a baby ghost in my hand. Oh, here we go. Is it going to work this time? Oh, there we go. So we've got that gas, carbon dioxide, and oh, it dropped on my hand and bounced off. And oh, there we go. And again. So what we've got here then, we've got that gas, carbon dioxide. Very, very heavy gas. Right, so we're going to finish off then looking a little bit more at this gas. So we're going to put the carbon dioxide gas in and we're able to get it bubbling away. Now, that's a bit crazy. I want you to have a look at this pink one here though. So what I had inside there was another chemical called phenolphthalein, and when it's in an alkali, it's very noisy, isn't it? It kind of gives me this pink color. But when it's in an acid, it kind of goes back to being clear. So whenever we're using all of this chemistry, we can have lots and lots of kind of magical things happening. So I can already see that the pink is starting to get lighter and lighter and lighter. So what we're going to do, we are going to, oh my goodness, look, it's kind of gone clear. So we are going to finish this session with, well, we talked about bath bombs, but really they were just bath fizzes. So I thought, let's finish the session with a proper bath bomb and knocking everything over here. So what we're going to need to do then is we're going to need to add in our bubble bath. So that's going to go in there. Already we've got a wonderful color change. So it should kind of go green. And if your water is slightly alkaline, then you're going to get that lovely blue color. Now I should really only put a small amount of citric acid in. And I thought, hey, it's the last demo. So let's put lots of citric acid in. So the citric acid is now in there. And then we can add in our baking soda. Now at the moment, this temperature, this water's about, I don't know, 70 degrees. Put in the baking soda. Yeah, it's looking bubbly. It's looking bubbly. I can put some more in. But if I add in my dry ice, then all of a sudden, oh my goodness, we're going to have a temperature difference of about 150 degrees. And then I end up with my table being completely covered with bubbles. So you have just seen Bath Time Science with Scientific Sue. I'm sorry about all the little technical problems we had, but this is the first time that we have done this. And we're going to repeat it again next Saturday, so hopefully a bit smoother. Let all your friends know. And I think if we kind of go back to my laptop, I could then maybe answer some questions. Hello. Don't touch anything else.
Yes, so we have a few questions coming in the chat, I think, to start with. So if I'll read it out to you first of all. There was a question from Claire Childs. Can you hear me okay, Sue? Sue, we've lost your sound again. We've lost your sound on your laptop. Oh, let me unmute you.
Oh, it's done again. How's
there
that?
You go. You're back. So you have a question from Claire Childs first of all. And if I could find that, how does giant bubble mixture work? It has a veterinary lubricant in it.
Yes, it does. It's called J-Lube, and you just need a small amount. it's what we call a polymer. So if we imagine that we were building one Lego car, and then we were able to join them together and join millions of them together. So we are able then to strengthen the bubble mixture. So at the moment, if it's just soap and water, because we've got that static force, we can only pull the water away from each molecule a certain amount. The soap going in allows us to go a little bit further. But if we add in this polymer, then that structure strengthens it a little bit and allows us to stretch it much further. But I think you'll find if you just use one measure of your washing up liquid, Fairy's Best, with 6 of water, you're still going to make some really big bubbles. It's only those that you want to be maybe 6 meters long that you actually really need the polymer for. So give it a go.